তো শুরু করি, হ্যাঁ? So basically, this is a part of the modern physics. Okay. Under the section of the modern physics, we have photoelectric effect, wave particle duality, okay, atomic physics, nuclear physics. Now, radioactivity is not there in the syllabus. It was earlierly included in the syllabus of class 12, but for the last 3 years, what I have observed, they have removed that part, no longer be a part of the syllabus of class 12. Now, nuclear radioactivity. Okay, good. Achha. So, the first topic will be your photoelectric effect. Photoelectric effect. So everything was started before the development of the concept of electron, because electron was first discovered in the year of 1897 by J.J. Thomson. Likely 20 to 25 years back, James Clerk Maxwell was the first scientist who first proposed the theoretical development of the electromagnetic wave. So at that time, there was no experimental verification has been done on the basis of the theory. So they are not ready to accept that concept of electromagnetic wave, that a such wave exists, which does not require any medium to travel, and it can transmit the light, heat, energy, and any kind of energy. So German scientist Henry Hertz. So this is the German scientist Henry Hertz. In year 1887, first started and try to set up an experiment which can experimentally prove the existence of electromagnetic wave. So electromagnetic wave, to prove such existence, he has developed two things. One is called transmitter, another one is called receiver. So here you can see, this is the receiving loop, this is the transmitting point. So basically, what was the expectation? There were two capacitor plates, okay? Zinc capacitor plates, metal rods are connected, and two sparking balls are there, spark balls. Now, with the induction coil, so have you ever used any induction coil in your life? No, that is an induction oven. Induction, that oven or induction cookware, something like that. This is induction coil. Uh, have you ever used a lighter, that a battery-based lighter? That battery-based lighter is basically an induction coil. Okay. What they used to do with that particular switch, they try to cut off the connection with a very small interval of time, due to which there is a huge change in the current, that is L di dt. EMF is equals to minus L di dt. You know that? So that creates a huge potential difference across that two points, and which leads to a spark. Okay, there are two sparking balls, S1 and S2, and which across we are connecting an induction coil and switch. So when we suddenly switch it off, there will be a huge potential difference has been developed due to this induction coil, because it's a mutual induction. Okay, due to high variation in the flux, it leads to a huge potential difference between these two, S1 and S2. So this spark is basically the oscillating electrons, and oscillating electrons develop a magnetic field as well as an electric field, oscillating electric field. So an oscillating electric field and an oscillating magnetic field collaborated together to form the electromagnetic waves. And that electromagnetic waves will transmit it through a medium less, that is in vacuum, through the vacuum. And on the other hand side, we have a receiver loop where this electromagnetic wave receives, and we can observe a small spark between these two sparking balls. That confirms this is a electromagnetic waves. Or sometimes we also connect a small bulb over here, which will be start glowing at the moment when it start receiving the electromagnetic wave. There are basic examples, basic experimental based observations nowadays available on YouTube. I will share a few videos regarding that where you can see they have developed a setup where this hard experiment has been replicated. Okay, that was good. There was no problem at all. But what they have observed during this experiment, if they placed a glass cover in front of the receiving loop, the sparkling becomes much less or almost zero. Okay, the frequency what they are developing for the transmitting end, it is of the order of electromagnetic, that ultraviolet rays. And ultraviolet rays has been cannot pass through the glass medium. So whenever we are placing a quart plate, it is easily passed through, and the receivers show the receiving of the electromagnetic waves and all. But on the other hand side, when we are placing a glass block or a glass slab in front of the receiving loop, we found there was no spark at all. That confirms there is some problem, or there is some physics lies behind this glass block and without having this glass block. So the discussion continues over here, and Hertz could not continue with these calculations and all our experiment. In 1892, Hertz passed away. So one of his disciple, we can say, at that time, Philip Ninard, who was a lab assistant of Henry Hertz, is also a physicist, German physicist, Philip Ninard. At that time, most of the young Germans are used to practice the physics experiments. So Philip Ninard was one of them. So Philip Ninard took the responsibility to continue this experiment. In 1895, I think Ron Jane first developed the X-ray, and Philip Leonard was developed something closer to it. And later on, we found the concept of electron from J.J. Thomson. And finally, in 1900, in the year 1900, he first developed a successful experiment of photoelectric effect. And that was a point where all the physics come to the stop. Because earlierly, in the beginning of the development of the light was treated as a rectilinear propagation rays. So it was either be discussed in terms of geometrical optics, or you can say ray optics. But from the James Clerk Maxwell, it start giving or discussion, and few observation has been proved theoretically, like interference diffractions on the basis of the electromagnetic waves theory. But this electromagnetic waves was not able to explain the phenomena what has been recorded by Philip Leonard experiment called photoelectric effect. So what was this photoelectric effect setup? What was the discussion? So there was a vacuum glass tube with two plates, metal plates. One was exposed to the light, which is coming through a quartz plate. Okay. And another one was the receiving plate, the second one. And it was slightly biased with the positive one. So what they have observed, when the light incident on this transmitting plate, the first plate, metallic plate, we found a small current is passing through closed circuit. And they named this current as photoelectric current, as the reason of this current is lies behind the photo or the light. Now, what they have observed, they have recorded the observed by varying few parameters of the light. like intensity, frequency. Also, they are vary the bias voltage connected to the receiving plate. They have observed few of the things are all of these parameters are going to affect the result of the photocurrent. But what cannot be explained, that particular fact, what they have observed or recorded, cannot be explained in terms of wave theory so far what has been developed for the new concepts of light. So they need some new theory to explain this phenomena, what they have recorded for photoelectric effect. And in 1905, scientist Albert Einstein first developed a theory with the help of the Planck quantization concept. With the help of the Planck quantization concept, and successfully explained all the phenomena, all the data has been recorded during the experiment of photoelectric effect. Later in 1922, they received the Nobel Prize for the development of photoelectric effect. Okay, so let's try to understand what they have observed and why it is not able to, why they are not able to explain this phenomena with the help of the electromagnetic waves. That means the failure of wave theory to explain the photoelectric effect. And what was the final theory explained or given by the Einstein in 1905, which was easily developed the concept or the theory or the fact lies behind the observation recorded in photoelectric effect. So that was the story lineup that we are going to follow this night for the photoelectric effect. So till now, I think there was no doubt because it was the story and year-based discussion. Now we are going deep in the discussion of the physics. Okay. Is it clear to everyone? Okay. Chalo. Let's start with the observation. Let's see what are the observations they have and why it is not been explained with the help of the wave theory of light. The first thing what they have observed, okay, let me list down. I think they have already been written. So let me list it down. What are the things? List one by one. Number one, increasing in intensity of light. এগুলো আমি লিখছি অবজারভেশন, যে অবজারভেশনস গুলো রেকর্ড করেছে। Increasing in intensity of light নামটা হচ্ছে ফটো ইলেকট্রিক এফেক্ট। ও লিনার এক্সপেরিমেন্ট। চলো লিস্ট ডাউন করে ফেলি। হ্যাঁ, নাম্বার ওয়ান, সাইজ ঠিক আছে না, বড় করে দেবো? চলো একটু বড়ই করে দিলাম। The photoelectric current, photocurrent, is directly depends upon the intensity of light, but the but beyond a particular value, beyond our value of frequency of incident light. concept of cutoff frequency. A minimum value of frequency of light must be maintained to observe the photoelectric effect. Okay, next. Concept of stopping potential. We will come to these concepts. Okay. Stopping potential. Stopping potential is independent of intensity of light, but it depends upon the frequency of light. And the fourth one, this one will be the third is okay. Okay, let's come back to the discussion. These are the three listed observations. Now let me explain how this observation has been made. Okay, this was the setup, basic setup. Let me bring a good one, photoelectric effect setup. Okay, so you can see this picture which explains the setup of the photoelectric effect. Okay, this is the emitter plate. This is your emitter plate, and there is a collector plate. You can see C and A, which is connected to an ammeter and the voltmeter and the variable voltage supply. Okay, there is a commutator. This is called commutator. Commutator will be used to switch the polarity of this battery. Okay, so battery is a fixed, no DC battery. This side is negative and this side is positive. Okay, so with the commutator, we can once make this collector plate relatively as the higher potential in with respect to the emitter one and the vice versa. Is it clear to everyone? Now, when light incident on this emitter plate without any biasness, what will happen? What they have observed, this emitter plate is start ejecting the electrons. The electrons are transmitting through this vacuum tube and finally collected by the collector plate. And this ammeter will record the amount of current which has been received through this circuit, which will be in terms of micrometer. Now we are connecting a supply, which create a biasness. So first, initially what we have made, collector plate becomes relatively positive or higher potential with respect to the emitter plate. So that helps the electrons, those who are coming out from the emitter plate, will be directly directed towards the collector one. Because electrons are negative, collector plate was connected to the positive end of the battery. So they start moving towards the collector plane, and we have a sufficient current in the ammeter. Clear? Now, what they have observed, if we keep the bias potential constant, if we keep the bias potential constant, and if we increase the intensity of light, if we increase the intensity of light, the amount of current which is passing through the circuit will also going to increase, and the graph will be looks like this. This is intensity versus photocurrent. Intensity given along the x direction, photocurrent along the y direction. It is linearly dependent upon the intensity of light. So keeping all other parameters such as frequency of the light and the bias potential across the plates are all remain constant. Understood? Clear? Okay. Now the next one, what they were expecting from the previous concept of wave. All of we have done with the wave, no? Not wave optics, but we have the basic idea about the wave. Yes or no? So if I ask you, a wave is carrying a certain amount of energy. So what is the main factor that dealing with the energy carried out by a wave? Which particular main factor, main parameter of the wave? Carrying out the energy of the wave. Huh? কোন particular parameter ওয়েভের এনার্জিটাকে ক্যারি করে ওয়েভ? অপশন দেব? ফ্রিকোয়েন্সি, ওয়েভলেন্থ, অ্যামপ্লিটিউড। কোনটা ক্যারি করে? মানে আমি যদি বলি ওয়েভের এনার্জি, তো বেসিক্যালি আমাদের মাথার মধ্যে কি আছে? অ্যামপ্লিটিউড, তাই না? That was the basic concepts. So if we increase the amplitude of the wave, any wave, the energy carried out by the wave will also be going to increase. Right? So if we now what we are expecting, the electrons are coming out now, and collector place is positive. So if we keep the intensity constant, and if we make this plate potential goes on decreasing and decreasing, and certainly it becomes negative. So what will happen? Negative means with respect to the emitter place, this is at a lower potential end. With respect to the emitter, if the collector goes to the lower potential end, so that means with respect to emitter, collector is a negative end. Yes or no? So the electrons will be repelled by this collector. Yes or no? হ্যাঁ কি না? ইলেকট্রনস গুলো কালেক্টর প্লেটের থেকে রিপেলড হবে কি হবে না? হবে তো? এবার প্রশ্নটা হচ্ছে, দাঁড়ান, এবার যদি আমি কালেক্টর পোটেনশিয়ালের নেগেটিভ পোটেনশিয়ালটা বাড়াতে থাকি, হোয়াট উইল হ্যাপেন? এই রিপালশনটা আরো বাড়তে থাকবে। For a certain negative potential at collector plate, ইলেকট্রনস গুলো আর এমিটার প্লেট থেকে বেরোতেই পারবে না। আটকে থাকবে, বেরোতেই পারবে না বাইরে, এতটা রিপালশন পাবে, ঠিক কি না? For that particular negative potential, যে নেগেটিভ পটেনশিয়াল আমরা কালেক্টর প্লেটে অ্যাপ্লাই করছি, যার জন্য এমিটার প্লেট থেকে আর ইলেকট্রনস গুলো বাইরে বেরিয়ে আসতে পারছে না, that particular negative potential is called stopping potential. বোঝা গেল? স্টপিং পটেনশিয়ালটা কি? ডেফিনেশনটা কোথায় লিখেছি আমি? এখানে কোথাও লেখা নেই সেরকম। So basically what is stopping potential is a negative potential applied to the collector plate such that electrons are no longer coming out from the emitter plate. ঠিক কি না? ক্লিয়ার? এবার আমি যদি ফ্রিকোয়েন্সি সেম রাখলাম লাইটের, okay, frequency remains the same value, remains at the same value, and the intensity of light has been increased. যে লাইটটা এসে এমিটার প্লেটের উপর ইনসিডেন্ট করছিল তার ইন্টেন্সিটিটাকে বাড়িয়ে দিলাম, তাহলে আরো বেশি এনার্জি আমি সাপ্লাই করছি ইলেকট্রনকে, হ্যাঁ কি না? ওয়েভ থিওরিতে তাই বলে, ঠিক তো? কিরে অনুরাগ, অরিজিৎ, যদি আমি লাইটের ফ্রিকোয়েন্সি সেমই রাখলাম কিন্তু ইন্টেন্সিটি বাড়িয়ে দিই, তাহলে আমি লার্জার এনার্জি প্রোভাইড করছি ইলেকট্রনকে। তাহলে আমি কি এক্সপেক্ট করব? যদি ইলেকট্রনের এনার্জি বেড়ে যায়, তাহলে আগে যে স্টপিং পটেনশিয়ালে আমি ইলেকট্রনকে স্টপ করতে পারছিলাম, এখন আমাকে তার চেয়েও বেশি নেগেটিভ পটেনশিয়াল অ্যাপ্লাই করতে হবে ইলেকট্রনকে স্টপ করার জন্য, হ্যাঁ কি না? কিন্তু এক্সপেরিমেন্টালি অবজার্ভ করে দেখা গেল, if we keep the frequency at a constant value and if we are going to increase the intensity of light, that is not going to affect the stopping potential. The stopping potential will remain the same. বোঝা গেল? For two different intensity of light, obviously the photocurrents are different in the positive biasness, but the stopping potential for both the intensities have the same value. এবং গ্রাফিক্যালি সেটাকে কিভাবে রিপ্রেজেন্ট করা হলো? এইভাবে, এটা ফটোকারেন্ট ভার্সেস এটা একটু বেটার ভাবে আমি আঁকতে পারি এখন। Okay, so both have the same stopping potential although the intensity of lights are different. ঠিক আছে? এটা হয়ে গেল ফার্স্ট কনফিউশন। কারণ ইন্টেন্সিটি বাড়াচ্ছি, আমি গ্রেটার এনার্জি প্রোভাইড করছি, বাট স্টিল আমার ইলেকট্রনকে স্টপ করতে হলে সেম এনার্জি বা সেম নেগেটিভ পোটেনশিয়ালি আমাকে অ্যাপ্লাই করতে হচ্ছে। এটা কন্ট্রাডিক্ট করে যাচ্ছে আমার ওয়েভ থিওরি কনসেপ্টের সাথে, ঠিক আছে? তখন ওরা একটা ভেরিয়েশন করলো। কি করলো? ইন্টেন্সিটি সেম রাখলো বাট ফ্রিকোয়েন্সি চেঞ্জ করে দিল, ফ্রিকোয়েন্সিকে বাড়িয়ে দিল, ঠিক আছে? যেখানে ν1 is greater than ν2 and minus v1 is minus v1 না লিখে আমি mod লিখি, modulus of v1 is greater than modulus of v2. That means greater negative potential we need to apply. If the frequency of light is going to increase, we need greater stopping potential. বোঝা গেল? মানে আমরা ইন্টেন্সিটি সেম রাখছি, থিওরি ওয়েভ থিওরি অনুযায়ী আমরা সেম এনার্জি প্রোভাইড করছি, কিন্তু ফ্রিকোয়েন্সি চেঞ্জ করতে আমাকে বেশি পরিমাণ স্টপিং পটেনশিয়াল অ্যাপ্লাই করতে হচ্ছে। কনসেপ্টটা কেমন ঘেঁটে যাচ্ছে ওয়েভ থিওরির সাথে, ওয়েভ থিওরি আর মেলাতে পারছে না, ঠিক আছে? এই দুটো হলো মেইন অবজারভেশন, ঠিক আছে। তখন ওরা স্টপিং পোটেনশিয়াল ভার্সেস ফ্রিকোয়েন্সির একটা গ্রাফ করলো। দেখা গেল ডিফারেন্ট ডিফারেন্ট মেটেরিয়ালস এর জন্য এই যে নিউ জিরো, নিউ ওয়ান, এই যে ডিফারেন্ট ডিফারেন্ট কাট অফ ফ্রিকোয়েন্সি আমরা পাচ্ছি। কাট অফ ফ্রিকোয়েন্সি মানে আমরা হাই ইন্টেন্সিটি লো ফ্রিকোয়েন্সি লাইট ইউজ করলেও মেটাল প্লেট থেকে ইলেকট্রনস আর বেরোচ্ছে না, যার জন্য আমাকে একটা মিনিমাম ফ্রিকোয়েন্সি মেনটেন করতে হচ্ছে। বোঝা গেল? মিনিমাম ফ্রিকোয়েন্সি মেনটেন করতে হচ্ছে, যেটাকে আমরা কাট অফ ফ্রিকোয়েন্সি বলছি। এবং এরপর ইন্টেন্সিটিকে সেম রেখে if we increase the frequency of light, we found the kinetic energy of the electron or the stopping potential is increasing linearly with the frequency. এবং ডিফারেন্ট ডিফারেন্ট মেটেরিয়ালের জন্য স্টপিং পোটেনশিয়াল, the cut off frequency different, but the lines are parallel to each other, মানে দুজনের স্লোপটা কিন্তু সেম। বোঝা গেল? অসুবিধা নেই? তাহলে ওয়েভ থিওরি দিয়ে কখনোই কোনো কাট অফ ফ্রিকোয়েন্সি কনসেপ্ট থাকা উচিত না। যদি আমি লো ফ্রিকোয়েন্সি হাই ইন্টেন্সিটি লাইটও প্রোভাইড করি, ইলেকট্রন সাফিসিয়েন্ট এনার্জি গ্যাদার করে মেটাল প্লেটের বাইরে বেরিয়ে আসা উচিত ছিল। তাহলে এটা একটা ঘটনা, নাম্বার ওয়ান। আর নাম্বার টু, ক্লাসিক্যাল ওয়েভ থিওরি, যে কোনো ক্লাসিক্যাল ফিনোমেনাতে একটা সার্টেন টাইম ল্যাপস থাকে, মানে ঘটনাটা শুরু হওয়া এবং ফলাফলের মাঝখানে একটা ফাইনাইট টাইম ল্যাপস দেখা যায়। কিন্তু এইখানে দেখা যাচ্ছে আমার যেই লাইট পড়ছে অমনি ইলেকট্রনস বেরিয়ে আসছে। ইটস এন ইনস্ট্যান্টেনিয়াস ফিনোমেনা which cannot be explained with the help of any classical theory. তাহলে অনেকগুলো ফেলিয়ার্স আমরা এখানে অবজার্ভ করলাম। ইন্টেন্সিটি উইথ দ্য গ্রেটার এনার্জি মিলছে না, ফ্রিকোয়েন্সি উইথ সেম ইন্টেন্সিটি এটাও এক্সপ্লেন করতে পারলো না, আর কনসেপ্ট অফ কাট অফ ফ্রিকোয়েন্সিও কিন্তু আমার ওয়েভ থিওরি এক্সপ্লেন করতে পারছে না। বোঝা গেল? অসুবিধা নেই? এই যে চারটে গ্রাফ ইজ ভেরি ইম্পর্টেন্ট, ঠিক আছে? এগুলো কিন্তু পরীক্ষা আঁকতে দেয়। Photocurrent versus stopping potential for different two intensity. Photocurrent versus bias voltage for same intensity, different frequency. তখন তোকে এগুলো কিন্তু আঁকতে হবে পরীক্ষায়, ড্র করতে হবে। বোঝা গেল? এখানে আরো একটা কনসেপ্ট আমরা ডেভেলপ করলাম, এই কাট অফ ফ্রিকোয়েন্সি থেকে শুরু করে সেটাকে বলা হচ্ছে ওয়াক ফাংশন। কি বলা হচ্ছে? ওয়াক ফাংশন। কি বলা হচ্ছে? দ্য মিনিমাম এনার্জি ইজ রিকোয়ার্ড to release one electron from the metal surface is called work function. ঠিক আছে? এই যে কাট অফ ফ্রিকোয়েন্সি এলো, কাট অফ ফ্রিকোয়েন্সি থেকেই আমরা বলছি যে মিনিমাম অ্যামাউন্টে একটা ওয়ার্ক ডান আমাকে করতেই হচ্ছে, যার জন্য আমরা এটা করতে পারি। বোঝা গেল? অসুবিধা নেই? ক্লিয়ার? চলবে? তাহলে ওয়েভ থিওরি গুলো ফেল করে গেছে, এবার আমাকে নতুন থিওরি নিয়ে আসতে হবে which is going to explain this phenomenon. ঠিক আছে? স্টার্টিং উইথ দ্য প্ল্যাঙ্কস থিওরি। এই 1900 যখন লিনার্ড ফটোইলেকট্রিক এফেক্ট পারফর্ম করছে, সেম টাইমে প্ল্যাঙ্ক তার কোয়ান্টাম থিওরি নিয়ে এলো। কোয়ান্টাম থিওরি কি বলছে? লাইট ইজ আ ফ্লো অফ branch of particles called photons, and the energy carried out by each of the photons is given by h into nu. Nu is the frequency of the light and h is called as Planck constant. ঠিক আছে? আইনস্টাইন এই প্ল্যাঙ্কের থিওরিকে ইউজ করলো এবং 1905 এ কনসেপ্ট অফ কোয়ান্টাম থিওরি যেটা ও এক্সপ্লেন করলো। কি বললো? দ্য টোটাল এনার্জি ট্রান্সফার, যে এনার্জিটা ও ট্রান্সফার করছে ডিউ টু কলিশনস, ফোটনের সাথে ইলেকট্রনের কলিশনসে যে এনার্জিটা ট্রান্সফার হচ্ছে, one part of this is to overcome the work function, the rest of the part will be used as the kinetic energy of the electron. Now, during these collisions, maybe the total energy of the photon is transferred to the electron, or a part of it is transferred to the electron. বোঝা গেল? Or else a part of it is transferred to the electrons. Whatever it is, transferred amount of energy, whatever be the energy transferred to the electron, one of its part is used to overcome the work function, and rest of the part is to increase the kinetic energy. বুঝলা? অসুবিধা নেই? So mathematically what we will write, h nu is the incident energy for the photon. So one of the part will be used for the work function. The rest of the part will be used as a kinetic energy. We will write Vmax. We will write Vmax, the maximum, because we are expecting the whole energy is transferred to the electron. Sometimes it happens, a part of it is transferred to the electron. Okay. So if we assume the whole energy is transferred, the corresponding kinetic energy will be considered as Kmax. Kmax. Understood? বোঝা গেছে? এবার কাইনেটিক এনার্জি কি ইকুয়েশনসে একদিকে রাখলে k is equals to h nu minus w0, yes or no? তাহলে আমরা এক্সপেরিমেন্টালি যে গ্রাফটা পেয়েছিলাম তাকে যদি কন্টিনিউ করি, they will have a negative cut off, negative that you may say section on the y axis, which will be considered as the work function of the metals. তাই না? Negative intercept on the y axis. বোঝা গেল? And the coefficient of the incident energy can be calculated from the slope. Either can be calculated from the slope. বোঝা গেল? যদি kinetic energy versus frequency plot করা হয়, then the slope, kinetic energy versus frequency plot করছি, তাহলে frequency coefficient এই তো slope নাকি? আমাদের ফর্মুলা কি? y is equals to mx plus c তো। তাহলে x এর কোএফিসিয়েন্ট এই তো স্লোপ, m টাই তো স্লোপ নাকি? So the coefficient of frequency, which is considered as h, so from the slope of this kinetic energy versus frequency will be given as a Planck constant. অসুবিধা আছে? আর এখন যদি গ্রাফটাকে আমি চেঞ্জ করে দিই, কি করে দেবো? ভালো করে দেব। If we change the graph along the y-axis, we are plotting stopping potential. Stopping potential. Along the x direction, we are having nu, the frequency. We will have the nature of the graph as the same. Now, this frequency intercept is the cutoff frequency. But the equation, if you do remember, that kinetic energy is equals to h nu minus w0. Yes or no? So if I divide it with charge of an electron, if I divide it with the charge of the electron, then kinetic energy is in terms of joule, na? Energy of the electron is given in terms of joule. So if V0 is the stopping potential, then definitely E into V0 is the energy associated with the electrons. Associated with electrons. কি ঠিক কি না? Energy associated with the electrons. কি ঠিক বললাম তো নাকি? So that means if I divide the kinetic energy by the charge of an electron, then the left hand side or the y will become the stopping potential. হ্যাঁ কি না? So it is equals to h by e into nu minus w0 by e. ঠিক আছে, clear? So this then from the slope of stopping potential versus frequency, if I consider the tan theta will be equals to h by e, or h is equals to e times of the slope. বোঝা গেল? Then from the stopping potential, we have to multiply the e with the slope to get the Planck constant. Sometimes in your examination, they may ask you how to get this Planck constant from the stopping potential versus frequency or kinetic energy versus frequency graph. From kinetic energy versus frequency, the slope is directly gives you the Planck constant. But for stopping potential versus frequency, it will gives you e times. You need to multiply e with the slope to get the Planck constant. বোঝা গেছে? কোনো ডাউট আছে? Okay. So now let me give you the different forms of the Einstein. If the first concept, the frequency of the incident light must be greater than the frequency, the cutoff frequency, so that the photoelectric effect can be observed. Number one. So in reverse way, we call threshold wavelength, cutoff frequency or threshold wavelength. If the wavelength of the light goes beyond the threshold value, then no photoelectric effect will be observed. So wavelength of the light should be below the threshold wavelength of the for the observing of a photoelectric effect. বোঝা গেছে? So the Einstein equation can be written. This is a standard form of that h nu incident light waves is equals to h nu naught. This is the work function. H nu naught is the work function. And E into V0 is the kinetic energy. বোঝা গেছে? Electron emission occurs if the wavelength of light is less than the threshold wavelength, then electron emission occurs. This is in terms of যদি wavelength of the light goes beyond of the threshold wavelength, then no photoelectric effect will be observed. ঠিক আছে? Now, in terms of wavelength, we have the equation like hc by lambda. In the place of nu, we have written c by lambda. Nu naught, we have written c by lambda naught. What is lambda naught? Is a threshold wavelength. Okay. Threshold wavelength plus the kinetic energy half mp square. Okay. So we are rewriting the equation E into V is equals to H nu minus W naught. So if we deal all the energy in terms of electron volt, please listen to this statement very carefully. If we deal all the voltage, all the energy in terms of electron volt, then the kinetic energy of the electrons will also be explained in terms of electron volt. Yes or no? That particular value itself is numerically equal to the stopping potential. Okay, I will show you a problem over here. এখানে একটা problem দেওয়া আছে। এটা হচ্ছে NCERT problem number 11.8, page number 408. Frequency of the incident is given. Velocity of the electrons are given. Mass of the electron is also given. ঠিক আছে? Fine. তাহলে এখান থেকে আমি কাইনেটিক এনার্জিটা পেয়ে যাচ্ছি, অসুবিধা নেই। H is constant, to H is known, mass is given, velocity is given. So সেখান থেকে আমরা এই ডিফারেন্সটা পেয়ে যাচ্ছি। আর কাট অফ ফ্রিকোয়েন্সিটা আমার দেওয়া আছে, মানে নিউ নটটা আমাকে বার করতে হবে, যেখানে আমাকে নিউটা দেওয়া আছে। তো নিউটা ইউজ করে আমি সেখান থেকে কাট অফ ফ্রিকোয়েন্সিটাকে বার, ঠিক আছে? আমি তোদেরকে একটা নিউমেরিক্যাল পড়াচ্ছি তারা পড়ছি। কোন গ্রাফগুলো এইগুলো? আমি একটু বড় করে দিই স্ক্রিনটা, সুবিধা হবে। ওকে, আচ্ছা, those who have Newton, they please take out the page number 960. And those who don't have Newton, don't worry, I will show the statement on the board. Okay? Or I will give you in the group. 960 তো অন্য কিছু তো থাকার কথা না। নিউ এডিশন, তোদের কি তোর কি এটা নিউ এডিশন? 960, 960। পাঠিয়ে দিচ্ছি। Check the picture given in the group. Question number 90, 19, 1990. Okay? Calculate the work function of a sodium metal in electron volt if the photoelectric threshold wavelength is given, that lambda is equals to 5400 Armstrong. Will photoelectric effect be observed, be emitted if the red light of wavelength 6800 Armstrong incident on the sodium? So this is your lambda 0, and lambda is given 6800 Armstrong. Now you can easily say that lambda is greater than the threshold wavelength. Yes or no? If lambda is the incident wavelength is greater than the threshold, will there be any photoelectric effect? No. So that means we will not observe any photoelectric effect for this wavelength. Now let's calculate the work function. Work function formula is simple, H nu naught. So instead of nu naught in terms of lambda, we will write Hc by lambda naught. Now let me give you a calculation for it. It is very easy. So 6.634 into 10 to the power minus 34 is the value for the Planck constant. Yes or no? So 6 to 6. Okay. 6 to 6. Into. What is the value of the C? Is 3 into 10 to the power 8. Divided by lambda naught is 5400 into 10 to the power minus 10 Armstrong to meter. Correct? But this should be in terms of joule. Now, to convert it into EV, we need to divide it with the value of the electron. Yes or no? Ten to the power 8 whole divided by 1.6 into 10 to the power minus 19 into 5400 into 10 to the power minus 10 joule. Now, instead of not joule, sorry, it will be in terms of EV. Okay. Now, listen. The value of this wavelength is given in terms of Armstrong, and we have written 5400 into 10 minus 10. So we can rewrite it in this way. 5.4 into 10 to the power minus 7. Can we write that? Yes or no? So now if we consider the 10 powers, they will all cancel with each other. So wavelength should always be expressed in terms of 10 to the power minus 7. Look, 10 to the power minus 34 into 10 to the power 8 divided by 10 to the power minus 19 into 10 to the power minus 7. Add the 19 plus 7, 26 plus 8, 34. Minus 34 and plus 34 will cancel. And that will gives you 1. Understood? So you will only leave with 6.626 into 3 divided by 1.6 into 5.4 electron volt. Understood? So do the calculation in your calculator and give me the value. কত? হ্যাঁ, মেন্সে আছে বলি তো আমি ট্রিকটা বললাম, যাতে তোদের ওই সময় সময় নষ্ট না করতে হয়। এত তাড়াতাড়ি কি করে করবি? 3 দিয়ে কাটলে 1.8, 6.626 divided by 1.8 into 1.6, তাই তো? তাহলে 662 divided by 16 into 18. ঠিক আছে? 2 দিয়ে কাটলে 331 by 16 into 9. Obviously 2 দিয়েও যাবে না, 3 দিয়েও যাবে না এটা। তাহলে 331 divided by কত হচ্ছে তলায়? 140. হ্যাঁ, so that is equals to 2.29 or 3 electron volt. 144 twice করলে কত হয় তুই বল? 288. অগ্নিজ, আরে 144 twice করলে তো 288 হবে। 288 তো 328 আর 288 এর মাঝে ডিফারেন্স কত? 328 আর 288 40। তো 40 বাই 1 তোর 140 করলে কত হয় মোরালেস? 4 by 14, 4 by 14, 4 by 14, তাই তো? 3 3 14 কত হয়? 3 14 42। তো ক্লোজার অ্যাজাম্পশন 2.3। No, no, done. Now number 23. Look into number 23. Number 23. What is it, a metal whose work function is given? Work function is given in terms of electron volt only, 3.0 electron volt. Okay. Illuminated by a wavelength is 3 into 10 to the power minus 7 meter. Calculate the threshold frequency, maximum energy of the electrons, stopping potential. Okay, understood? So if this is the incident wavelength, then what is the incident energy? Hc by lambda 6.6 into 10 to the minus 34 into 3 into 10 to the power 8 divided by 1.6 into 10 to the power minus 19 into 3 into 10 to the power minus 7. 3 cancels. 6.6 divided by 1.6. 66 divided by 16. 4.125 electron volt. Correct? This is the incident energy. So what is the kinetic energy of the electrons? That incident energy E minus work function. Okay? That is 1.125 electron volt. Correct? So I told you, if the kinetic energy of the electron expressed in terms of electron volt, numerically that is equals to the stopping potential. Clear? Any doubt? Minus থাকবে, negative potential definitely. আমরা শুধু mod ভ্যালুটা কনসিডার করছি। Okay, so what is in terms of joule then? 1.125 into 1.6 into 10 to the power minus 19 joule. That is the kinetic energy. That is equals to 1.8 into 10 to the power minus 19 joule. Correct? And to have the frequency which is associated with the work function, so we can easily write work function is equals to 3 into 1.6 into 10 to the power minus 19 joule first. We need to consider that is 4.8 into 10 to the power minus 19 joule. That is equals to H nu. So nu is equals to 4.8 into 10 to the power minus 19 divided by 6.6 into 10 to the power minus 34. Okay. So 4.8 into 10 to the power minus 19 divided by 6.6 into 10 to the power minus 34. That is 6.82 into 10 to the power 14 hertz. Oh, no, no, sorry. Sorry, I'm calculation error. It will be 7.3, 7.27 into 10 to the 14 hertz. ঠিক আছে? বোঝা গেছে অঙ্কগুলো কি করে হচ্ছে? হ্যাঁ, সেম জিনিস। এবার ফিজিক্সেও লাগবে 12-এ এটাতে। তোরা ডিবগলি ওয়েভ থিওরিও পড়েছিস, আর শ্রডিঙ্গার ইকুয়েশনসও পড়েছিস। পড়েছিস তো? হ্যাঁ, রিভিশন তো হচ্ছে ডেফিনেটলি। ওকে। হ্যাঁ আছে। ওকে, সে তোরা ভালো বুঝতে বলতে পারবি, কারণ আমার কেমিস্ট্রি নিয়ে কোনো আইডিয়া নেই কি আছে। যাক, এই যে, ঠিক আছে। So the photoelectric part is done, completed.